you have told me what an alternating series is. Here is the alternating series test.
We're recording now, right?
Yes.
There's some inequality. Oh no. Hi, Sean. Hello.
So what does this, well, write it down first, those of you who take notes.
Okay.
Mm-hmm.
No, I have notes. And more notes. Actually, that's that round table thingy. But more notes here.
Why I think I almost never use them.
That is a bold statement to make.
Okay. Okay.
This is like the nth term test plus a
Okay. So yes, this is basically saying, all right, it passes the nth term test. And what does this mean?
It's decreasing.
Okay, decreasing. What are ways we can show that a sequence is decreasing? What else?
Plug and shove.
Plug in
Probably
plus one.
some of these tests we just integral test.
Plug in n plus 1 show that it is less than any value.
Yeah. Yes.
There are three ways.
Derivatives.
Derivative was one.
Okay.
You could look at the difference of a sub n plus 1 and a sub n, and it would need to be
Greater than the difference of a sub n.
It's non-zero and not negative. Yeah. The whole number.
positive. If we're decreasing, right?
Yes.
Or we could look at the ratio of a sub n plus 1 to a sub n, and it would need to be
Greater than one.
bigger than 1.
Or equal to.
Ace. Oh, ace.
No.
If we're looking at a sub n plus 1 over a sub n,
Shouldn't that be less than one?
yes. Yes. I was thinking backwards.
Okay.
Okay, so there's the three ways. Now, we like derivatives because we're in calculus. However, if our sequence was 1 over n factorial, you're probably not going to do the
Is there derivatives for that?
The product rule.
the infinite product rule. Okay, now what I want you to notice is that a sub n is referring to the sequence that is being multiplied to that alternating piece. Okay, so there's the sequence times the negative 1 to something. You notice that? So the negative 1 to whatever power it is tells us that it's alternating, and so then we have to make sure that this a sub n satisfies these two things. So it's a very simple test.
Okay.
Okay, so 1 over n is the a sub n in this case. Now we know it's alternating because we have the negative 1 to the n plus 1. Okay, so we need to check two things. We need to check the limit as n approaches infinity of 1 over n.
So it's just the sequence, not the series.
It is the sequence, correct.
I guess it's the series type of.
Then we need to make sure we're decreasing. How would you like to prove that in this case?
If you just do the derivative, it comes up to -1 over x squared.
The derivative is probably the quickest in this case. Because if we do the difference, we'd have to get common denominators.
So what if you get a negative end on Good for you.
N equals 1 or greater.
Oh, yeah, I know.
Okay, so this is less than 0, which means we are decreasing, which means we're good. Therefore, this converges by the alternating series test.
Even if 1 over n doesn't actually work.
But, okay, hold on.
Okay.
Some of you are bothered because you know 1 over n by
But it's a
itself.
sum.
Is that right? Where is that right?
Even
Well, yeah, because we're adding, because it's an alternating series. So let's imagine what we're adding. We're adding 1 minus 1/2 plus a third minus 1/4 plus a fifth, right?
Yeah.
Let's look at another one.
Okay. Ah. Ew.
Why is this one so scary?
Yeah. Radical. Yep.
Oh no,
There's a
radical.
sigma.
And a fraction.
There's a sigma.
And there's an infinity over there.
I thought that was just a sign.
Every time I write a sigma, I always want to put the n.
Okay. All right. So first of all, what is a sub n?
1 over n greater than n.
Yeah.
Okay.
I guess it's
Limit towards infinity is 0. Okay. So it passes the nth term test essentially. Now it's alternating. Let's make sure we are decreasing. As long as we're alternating and our a sub n is decreasing, with that limit towards 0, we're going to converge. How would you like to do that?
Derivative.
Derivative's probably going to be the best bet again. So our derivative is negative 1/2 n to the negative 3/2, which, no matter what n is, will always be negative, which means we're decreasing. So this converges by the alternating series test. Even though what? Okay, so we're still a little bothered that if that didn't have the negative 1 to the n, it wouldn't. Okay, hang on to that thought.
Ah.
And what?
That toy.
Last
That's the last.
Just
That.
that.
Let me see.
Okay, so this is an alternating series, which means we just have to look at the limits and whether it's decreasing. I'm going to go for red this time. The limit.
Let's divide this.
No. The limit as n approaches infinity.
0.
Okay. Now, we are not going to take.
Ratio.
Okay. I would say the ratio test. The ratio is going to be our best bet to find this because I don't think you really want to do. I mean, you could do the difference, but it'd take a little bit of work.
Okay.
Let's talk about the ratio. So 1 over n plus 1 factorial over 1 over n factorial.
No, I guess you can do it. This one just has to be.
have a sub n plus 1 over a sub n. What does this simplify to? Does everyone agree with that
Yeah,
and know how that happens?
yeah.
You see why we practice that?
Yeah.
Okay, so is this bigger than 1 or less than 1?
Less.
Which means what about our sequence? Therefore, this converges by the alternating series test.
Not
Are you complaining?
Yes.
I want school to go. I want school to schedule tomorrow, so he can't do this Sunday.
Just write it down if that's what you like to do.
Wow.
So, this one looks kind of.
What do you know? It is alternate.
What's the cosine of pi?
One,
What's the cosine of 2 pi?
0.
Right?
One.
What's the cosine of 3 pi?
Negative pi. One.
What's the cosine of 4 pi?
One.
Okay.
Wait, let me pull out decimals.
So we have 1, negative 1, 1, negative 1, 1, negative 1. This is really,
Whoa.
okay, you are probably going to see cosine of pi n.
I guess.
Yeah.
What about sine of n pi over 2?
That wouldn't work out so well. When you put
You get 2 pi over 2.
Yeah.
So is this how we can say that
One.
the
Could you
name,
do it?
as n goes infinity or whatever, like
Do
cosine
it.
is 0?
Now you can do
Right?
that.
Can we say that or not? I'm just misremembering.
maybe cosine x over x. Or sine x over x.
Never mind.
Okay.
I'm thinking something else.
All right, so
A sub n here is
okay, the limit as n approaches infinity. What is a sub n in this alternating series?
that's not 0.
So this diverges. I would say by the nth term test. I know it's an alternating series, but
So if an alternating series doesn't converge by the divergence,
what?
the alternating series test, if it doesn't prove convergence, it proves divergence.
Unlike the nth term test will prove divergence, but won't prove convergence.
Okay. Let me sort my thoughts.
Okay,
Or is it literally just the nth term test?
Well, I mean, A is the nth term test. If it passes A and fails B, I would say that it diverges by the alternating series test. Okay. So now, some of us were bothered by my first 2 examples. Negative 1 to the n plus 1 over n. Right? Because without that alternating piece, what's true about that series? It diverges. Okay. So, when we have alternating series, if they converge, they can be absolutely convergent or they can be conditionally convergent. Okay? What would it mean to be conditionally convergent?
only if it's alternating.
It's only convergent if it's alternating. Absolutely convergent. It's convergent with the alternating series piece or without it. Okay? So, if we take away that negative 1 to the power, which is really just putting an absolute value over it, right? I like to think of it, though, as taking that negative 1 to the power out. Okay? If it still converges without that negative 1 to the power, then it's absolutely convergent. If it doesn't converge, if it diverges without that -1 to the power, then it's conditionally convergent. It's only convergent because it's alternating.
Is the snow sticking to the
No, it's wet. It's too warm for it to stick. Because it's like, isn't it 40?
maybe?
Oh, it was supposed to get.
Oh,
So if it was sticking.
Well, it's 30 degrees right now, so it's not.
did you change
Measure
it?
the stick, we would just probably go average. So the ace of n card, in an alternating series represents the absolute value of this stuff. I mean,
Okay, so let's go back to one of our examples here. Well, it looks slightly different. Okay, so I want to know whether this is absolutely or conditionally convergent. So first of all, we need to prove that it's convergent. Because it's an alternating series, right? Which we already did this, right? We said, okay, the limit as n approaches infinity of 1 over the square root of n is 0. And then we went ahead and said the derivative was -1 over 2 to the 3/2, which is always negative, which means we're decreasing. Therefore, we know this converges by the alternating series test. Okay? Well, now we need to look at the series of 1 over the square root of n. What do we know about that? Okay? It diverges because it's a p series where p is less than or equal to 1. So we have an alternating series that converges, but the absolute value of it diverges. So this alternating series converges conditionally.
What does that mean for the sum? Like, the sum would be finite only sometimes?
Only if it all.
It's only going to converge if it's the alternating.
Okay.
Do all
Is that what you're asking?
alternating series converge to 0?
And I'll show you how to approximate their sum. Right? Because we don't really have a good way of finding their sum, but we're going to be able to approximate their sum using an alternating series remainder.
Using Riemann sums. So it's you're gonna have to use like multiple things. Like the comparison, or the limit line. Sorry.
First of all, let's talk about the alternating series, because this has to converge before we say it converges absolutely or conditionally. Okay? What's the limit of a sub n? How would you like to prove it's decreasing? Okay, because the derivative is -2 over n plus 1 to the third. which is always less than 0, which is always decreasing. Okay. So we have a convergent alternating series. Okay, is it convergent conditionally or absolutely? In order to figure that out, we need to look at this.
Those two are from,
I'm just kind of separating my work, which I guess I'm doing with colors, but I'm just kind of, no, I just want to separate things. Okay, how do you want to prove this?
the
LSD.
direct comparison test.
The direct comparison test? Okay, so what are we going to compare it to?
1 over n squared.
We can compare this
The limit. Let's do a limit.
to 1 over n squared. Okay, we could actually do either one. Okay, so we can do limit or we can do direct, because this would be pretty easy to see that this one is smaller, right? We first should probably say that this is a convergent P series, right? Okay. Doesn't matter which one we use. The limit would be 1, which is positive and finite. So we know that this also converges, right?
Therefore, it's absolute.
Therefore, okay, so our alternating series converges. We take the absolute value of it, it still converges, so we say this is absolutely convergent.
Absolutely not positive.
And excuse my corky brain. A lot of words to write. Okay, last thing we need to talk about, which actually is going to come up quite a bit in the free response portion of one of these problems, okay? When we talk about the AP test, which by the way, somebody's coming to talk about dual enrollment on Monday, so keep that in mind. When we talk about the AP test, you have 6 free response questions. No matter what, one of them will be some sort of series question. Okay. And the alternating series remainder is important. We cannot figure out what the sum is, but we can approximate the sum using a remainder. Okay, so S stands for the sum. S of n is the sum that we're approximating. Okay, so basically this is saying that the difference between the actual sum and what we approximated as is going to be less than or equal to the next term. The sum and what we approximate the sum to be. So if we approximate the sum with 7 terms, then the actual sum will only differ from that approximation by whatever the eighth term is. Do I need to explain that? So we're doing example. I'll wait for everyone to write down what they need to. Those main statements. It just surprises me how many, I don't know.
How many? How many of us know?
Sean. Oh, good. They're not so small, sorry. So I want to approximate the sum using the fifth partial sum. That's what that means.
Thank you for your already studying.
Now, we already looked at this one, right? Okay. Was it the n plus 1? What did you just say?
N.
That is what my class last year did all the time.
Calc BC class.
Yes. When we worked with these, instead of like n factorial, they just yell n really loud.
Yeah.
Okay.
I can't believe I didn't get
So
that.
the fifth partial sum. You can use your calculator. Go ahead and flip those out for me. You can either punch this in one by one, or you can use the shortcuts. Math 0 for a TI-84. Right? Math 0. If you have an 83, watch me please, you'd have to say second stat and go to math. Here's the sum.
Is it just x or is it x plus 1?
And then
It's just n.
And then second stat under operations is the sequence. We would write in -1 raised to the n plus 1 power divided by n factorial. And then we have to say what our variable is. And we're going to sum it from 1 to 5, correct? Right? If you have a TA83, this kind of stinks, huh? Did I plug it in wrong?
Right?
I got that.
Okay. Don't forget the parentheses around the x plus 1 for your exponent. So our sum is 0.63333. Right? Now, what would the sixth term be?
Negative. 1 over 6.
A sub n plus 1.
What's 1 over 6 factorial?
1 over 720.
So -1 over 720, which is approximately
.00138888889.
Wait,
Probably.
Okay.
It's 1 on 8, actually.
So our sum differs from 0.633333 by this much. Okay? So our sum would be between,
Uh-oh.
please take 0.63333 plus 0.00139. Okay? And then we'll go the other way, we'll subtract.
oh, okay.
That's continuation.
Okay? So we know our sum is between those two numbers. We've approximated our sum to
A lot of significant.
a little over the 1,000.
Wow.
Yes, confidence.
Okay? The more terms we add, the more accurate we're going to be. Yeah?
So you can technically.
So, these all don't add up to be 0.
What?
Well, he was asking if they all added up to be 0.
Yeah.
Okay. So, here is your homework. I have some specific instructions. So 27 to 28, it asks you to find the specific sum, but then I also want you to find, so I want you to find the error and the interval the sum will lie in. So find like that remainder
Oh,
and give me the interval that the sum would actually lie in.
I think you're missing a preposition. Whether it's in or on.
Yeah. Well, it still works.
In which the sum would understand.
That's fancy.